Boston Linux and UNIX virtual meeting. We're going to be talking about RISC-V with Federico Lucifredi and Kurt Kebbel. And I think Federico is going to start us off.
Mm-hmm. Oh, and Joshua said he's going to be talking later too.
Excellent. So I have managed to collect 5 different SBCs from around the lab that we can poke at. One may even be working, although I haven't used it in a while. So let's start with the specs. So I have here the first one, the BLU Fire. So this one we have spoken about before. I can't remember. It was a year or so ago. Again, with Kurt, we were talking about FPGAs. Because at the time, the BeagleBoard Foundation had introduced 2 different RISC-V systems, and so they were capturing all our attention. Now, if you look at, I know that there are too many screens here, but the one where I'm showing the desktop, the BLU Fire should be, if I remember correctly, $149, unless it's become cheaper. It's an SBC in the standard BeagleBone format. I can't seem to switch my screen. One sec. That is kind of a problem.
Yeah, can you maximize that or something?
I can maximize it, but yeah, well, I can at least maximize that. I cannot solve the problem on my end, but one problem at a time. So as I said, it should be 149. Let's see. Let's double check just in case it has changed. Well, looks like Mauser is a little bit cheaper. 138 it says here.
You think maybe you can increase the font size?
I'm going to do something else.
Oh, okay.
And so layout. It's a fairly standard BeagleBone, so not too many surprises here. The 2 cape headers, 2 buttons, reset and user, as pretty much any recent BeagleBone. What is this header? Oh, it's the user LEDs. That is new to me. So it looks like there are 10 or so user LEDs. Standard network connection. The screw terminals over here are for power. So in a more industrial application, you can bring the power in with screw terminals, which is convenient. USB-C for power and connectivity. So the connector is updated from the original BeagleBones. There is a power LED right behind the USB connector. And nicely, as usual on the BeagleBone, the JTAG pins are here on the bottom left corner. So you can bring out a JTAG if you have an emulator for it. Calling out the RTL8211F here, the chip that's powering the Ethernet. I don't think we particularly care. Bits that are interesting to me are there are 16 gigs of eMMC on board, so you don't need to play with micro SD cards, and not only that, it's more reliable this way. Obviously, you have to flash this to the system that you want, so have a little bit more upfront work, but then you don't have to deal with the flakiness of micro SD cards as you do on Raspberry Pis. The RAM is at 2 gigs LPDDR4, which seems all right. And then we have the PolarFire SoC. There is an M2 connector for probably storage, but theoretically you could put almost any PCIe device there. And there is a CSI connector for the camera. More accessible than the JTAG over here is the serial port up here. And let's look at the specs, since we care specifically about the RISC. Let's look at that first. I'm sorry, somebody is typing with fury and no muted microphone, so there is a lot of typing in the audio. Thank you. So PolarFire is the SoC. It's made by Microchip. Kurt can tell you everything about the FPGA, but here are the specs of the FPGA part. 23,000 logical elements, 68 math blocks. The microprocessor is the part that I'm interested in. Monitor boot core E51 and 4 application cores, U54MC. And it's giving us 1.714 DMIPS megahertz as some benchmark here that I don't particularly frequent, but that's what we have. And the memory interface has DDR4, DDR3, LPDDR4. In this case, the board is using LPDDR4. The chipset is supporting the gigabit Ethernet directly, as were used in many other SBCs, so no surprise there. 2 PCIe generation 2 lanes. Memory is made by Kingston. I'm sorry, the memory I think is made by UNIX. The storage is made by Kingston. And there are 128 megabit of SPI flash. This is the bootloader. Let's see, anything else here interesting? Syzygy high-speed connector, camera connector. Already covered the screw terminal. The serial is 3.3 volts. Seems to be common these days. Now, this one was released a couple of years back. It's not super new. But the thing that was significant of this, if I can bring it, let's see where it is. It should be here. Yes. So now let's try to use the other camera. As usual, all my systems are in these cases made by Seed Studio that I find very handy to work with, so that I don't accidentally destroy something with a static discharge or because it falls off the desk or anything like that. These are very nicely made, and Mauser once or twice a year has a sale on them, so one can get them without paying too much. And the top is magnetically latched, so you can take it off to do work. Oh, this is the ahead. This is not the fire. Oh, I'm getting ahead of myself. Too new. You need the older one. The fire is here. Okay. Too many SBCs in this lab. Okay. So the ahead is slightly older than the fire, and it doesn't have the FPGA. So let's look at the fire first. So what does it say? Project 105.
Are you trying to show the boards with the camera? Because we're just seeing the web page.
I am trying. Oh, interesting. What happened here?
Does somebody have admin control to highlight the camera of Federico's desktop?
Let me see.
Or we can all just go into Brady Bunch mode and select it, and now that we know that we need to.
If I do an action in Jitsi, I'm always not sure if I'm doing it for me or for everyone.
It's rarely for everyone, sadly.
I can do it for myself, but I cannot seem to.
Okay, I just did it on where the recording was. I clicked on it, and now we're seeing your device there.
Yeah, to
I'm not
be
sure that.
generally useful, I think you'd have to switch your microphone to being on the desktop.
Anyway, everyone turn on the video view and look at Federico's desktop.
Well, we need to switch over because otherwise Jabber will not get his recording right.
He said he manually switched the recording.
Oh, okay, excellent.
But as you pointed out to me, the other possibility is to use the OBS, but
I wasn't sure what I had done at first. I just looked closely and I see a little push button. Just changed again.
now he left.
Oh, did Federico leave?
His desktop
No,
left.
I'm still here.
Federico and
Oh.
Federico's screen are here, but desktop left.
Okay, look, Federico had his desktop displaying, and there was a column of.
I sent the command.
On the
I
right.
think that was me. I sent the command move to viewer, and I thought that was going to be something good, but that was something bad. How do I undo that now?
I'm going to turn off pretty much on this thing. Desktop, and I'm not sure what I did, but the push pin appeared when I did this earlier. It's not shifting now.
Well, while you do that, I will change.
You know, I'm
The
seeing
way.
Federico's paintings on the wall.
Right, that's my
okay,
my
now,
computer. It's
right.
not my iPhone.
And now I'm seeing your web page.
That's the shared screen. And then there is the third one.
Well, I'm not seeing what the third one is. Maybe I need to scroll up or down to find it. And that's scrolling. Oh, scrolling really take a long time to scroll. Let's see.
The third one told me it disconnected and disappeared.
Yeah, that was
Interesting.
right
Well,
after I said, that was right after I said, move this person to viewer, and I thought that was gonna be a good thing, but it was a bad thing.
Yeah, I think you
Okay.
removed his privileges.
Yeah, how do I undo
let
that?
me
I'm not clicking
rejoin that.
anything anymore.
Yeah, the easy way is to drop and rejoin.
Okay, we'll do that.
Sorry about that.
No worries. We're all learning.
It
Jitsi
was
needs to say like what if something is an admin thing or not.
yeah, it was ambiguous.
Okay,
Okay,
so now
now
I
I
need to
need to
read
read
to. Okay, can you still hear me?
And if you now mute the microphone on
Yeah, he
regular
did.
Federico, the microphone on the probe camera will hold focus when you're sharing that camera. And if you flip the muting when you are back to wanting us to look at your face or the screen, that way you can that will indicate the recording should follow.
Okay, let's try. All right. So now I'm unmuted on the camera. Can you see anything?
Let me click on Federico T. Okay, now I'm seeing Federico's desktop. It's just a little black background with a circle that says FD in the middle of it.
Yeah, it's not sharing the camera yet.
Oh, okay. Okay, now I see Federico's face in the ceiling.
Uh-huh.
Need to switch to the other. Yeah, there you go.
We can always see the machines in the desktop.
Okay. So have the usual problem of things being flipped,
Again,
but we'll manage.
I'm seeing the machines on the frame buffer that's recording the meeting, but in my regular desktop view, I'm still just seeing the web page.
Yeah, me too. Oh, okay. Now Bill's theory panned out. All right. So that is the fire. It's not fully set up in this unit. A proper full setup would sorry, I'm having trouble speaking while I hear myself in the back.
I just noticed in the frame buffer where it's seeing the right view, there's a thing at the top now that says sharing this tab with Jitsi, and the stop sharing button. Okay, that's not going to mean anything, I guess.
All right, so let's try this again. The BLU fire is here. It's not fully set up, as you can see, because normally in one of my setups, you would see things that look more like this. Let me open this one. Where you'd have the antenna, a video connector, and a few other things already set up. But the fire was never set up for lab use. So apparently I figured out that I wanted to use this as the UART to USB bridge. But I never fully set up the rest because I wasn't going to do the FPGA. However, because it becomes quickly impossible to find all the parts if you don't buy them all at once. And let me see what is that I sourced for FPGA. we have, these are the parts that support that board. So the UART is nothing special. I think it's apart from Adafruit with the right voltage. But to do the FPGA setup, you need a lot more. And so there is this Flash Pro 5 that was apparently the most economical way to get that done. I am not an FPGA designer like Kurt's students, so I was more interested on the microprocessor side of this. Well, my earpiece is running out of power, so we're going to have another adventure switching the microphones. But let's finish with this board first. So this is the microchip implementation we were saying. Let's see. This is at least 2 years old, maybe 2.5. But if we go 3 years old, oops. Actually, the copyright is very useful here. The file was made in October of 2023, so a little bit over 2 years. The ahead is 2.5 years, May of 2023. And it's over here. So this is actually properly set up. I don't remember why. Maybe in the last SOC roundup, we went over this. But this is fully set up to my lab standards. So you can see connector with the adapter to full size. The Wi-Fi antenna is wired in. And there is over here, similar to the other one, a UART to USB. So that essentially you can pull this from the shelf, give it power, and start working. And this one, let's see if I can follow Bill's theory. I'll switch this on. Can you still hear me?
Yep.
Excellent.
But it didn't center your other one. Alas.
I'm sorry?
You're
hearing a feedback?
No, well, yes, but that's me. Maybe not. But it didn't pop over to your face. I'm manually selecting your face.
Right. But it's not my face that you want to select, is the shared screen. So I'm going to go over there. And let me see, did I have this one open? Yes, I do. Okay. Ah, I know why. Okay. So the ahead, which we said is 6 months older, is only a RISC-V core, and actually only is a little bit diminutive because while the preloaded image, which I think was what's the build system that was pioneered by Intel? For Linux distributions. Yocto, there we go. So the Yocto image that came with the system was a little bit of a letdown. It would boot to essentially a dead screen. And I can't remember if it was because it didn't support the HDMI port, or if it was because it was set to some strange frequency. But essentially, it came preloaded with Yocto, and booting Yocto would not get you anything on the HDMI port, which was kind of confusing. But if you had set up the serial, like I did, that was fine because you would see the console pop up on the serial. The other software image that you can load is Ubuntu, or was Ubuntu. Looks like it still is. And that build of Ubuntu supported both init 3 and init 5. And the results were actually quite dramatic in terms of how smooth the experience on RISC-V was. It was the first time really that I had a pleasant experience on a RISC-V system. As I said, the first bootstrap wasn't too cool, but once I worked around that, the experience on Ubuntu was almost indistinguishable from an ARM experience. This is a more traditional, if possible, BeagleBone setup. It still has the micro SD, the power, video out is micro HDMI, which is why you saw that that adapter that's in the box. Same memory as we discussed, 2 gigabytes. It has also Wi-Fi support. It has a power connector with a barrel connector. I remember that part of my setup adventures involved that because you can power the board over USB, but I was flashing the storage to switch from the Yocto image to the Ubuntu image, and to be able to do that, you have to use USB for data, not for power. So obviously I had to figure that one out. Not too unexpected, but instead of using the micro USB power, which you can use all the time when you have flashed the system, when you're flashing the system, you want to use the barrel jack power and use the micro USB connection from a Linux laptop that's being set up to be able to flash the system. And from there, you can either flash a pre-prepared image like the Ubuntu image that is downloadable here, or and here is the part where Yocto is handy. If you have a Yocto build system on your laptop, you can build your image and rebuild it to your heart's content until it's the way you want it. That's the beauty of Yocto. If you put in the time, you can customize everything. So DSI display for LED, a couple of connectors for cameras, similar to the ones that we're used to on Raspberry Pi, nothing too strange. Wi-Fi connector, this one on the table that is also wired, as you can see, with sticker antenna. And let's see, if I remember correctly, this one has, yes, see, this one has, see the note, commerce restricted, not for export. It's because I had to declare that this would not be re-exported because, funnily, this is a Jointier processor. So it's made by Alibaba's semiconductor division. And so it's not made in the United States, but to get in the way of these chips becoming too popular, the Commerce Department restricts trading in them, so you can bring them into the country, but then you cannot send them back out, which is kind of strange, but that's
So
how
that
it
if one of your customers wanted to use them, they'd have to order directly from China, preventing us from getting a markup.
Yeah, well, that, yes, but
Makes
obviously
a hell of a
this,
lot of sense.
well, you know, it gums up the works so much that you probably choose to use another processor. At least that's what the Commerce Department thinks. And maybe true when the difference is minor. So, right, so this is an Alibaba T-Head TH1520. I think that Alibaba also has high-end versions of their processor, but this is the SoC version. This board, apparently, really? I was convinced. Oh, that's right. There are two chips there, not one. On the flip side, though, I cannot see it here, but I can see it there. Yeah, there are two chips here. This is a 4 gigabyte RAM board, not 2 gigs like the other one. So no FPGA, but twice the RAM. What else? The barrel connector is 5 volts, just in case you need to hear it, not to release the magic smoke. Antennas are 2.4 gigahertz and 5 gigahertz, which you would be surprised how many devices have limp antennas when you look at things produced 2 or 3 years ago. They have these messy devices that have only 2.4 gigahertz antennas, and you discover it only when you actually need it. The storage is the same, 16 gigs. And what is this? Super speed USB 3 programming cable. Right, that's the cable I use to program it, but oh, that's right. See, the USB connection there is one of those micro B connectors, which are the two-part micro connectors, which I absolutely hate, but a number of storage vendors use them, so I have those cables around. Okay, well, let me see if there is any other hardware that's relevant with the kit here, but I don't think so. It's probably just that cable. And yeah, let's see if you can see it. It's just that USB cable to be able to program it, and the other one is a short USB-C power cable because the laptop I was using only has USB-C, so that's more convenient for me because I needed the flash tooling to flash the eMMC. Not as involved as flashing the FPGA. No programmer here, just USB cable is all that's needed. So That one is neat, and if we have time, we can actually try to start it up. It should be just fine. We just have to figure out how we're going to USB to it. But the main part about it is how uneventful it is. You're just booting Ubuntu, and you don't know that it's RISC-V unless you look. So that's a very nice milestone. Let's see. Excuse me. What is next here? So I think let's go with logical order. This one is a project that I'm actually working on to write an article in the short term. And it should be interesting to those of you that remember the Apple II. So as a matter of fact, there is an Apple II here. That is in the process of getting turned into a transparent case. And there is another Apple II over here, just because it's cool. So a 2C and a 2E. But those are just retro computing fun. Let's see, I'm messing with the connector here. Let's hope I haven't. Okay. So I keep the in progress things in cigar boxes, just because they are a different standard from the Seed Studio cases, but they are equally unlikely to generate shorts. So when something is not fully built out, it lives in a cigar box. And the thing that we have here is this board. Let's see, which is an Olimex RVPC. So Olimex is a company out of Bulgaria that does interesting open hardware. Now, if you can see from my hands, this is a very small box. It's maybe 2.5 inches by 2.5 inches. Olimex makes a number of embedded and automation boards, primarily for industrial use. Let me see. Well, somebody is commenting that they cannot see the Federico's desktop screen. They may have to manually select it.
I'm having to manually transition again.
Okay, thank you. So yeah, this is the board. Like I was saying, is maybe 2.5 inches box, not a very big box, and this is the board that's in there. This is a very simple board exposing a RISC-V processor. But the thing that's interesting about it is that it's meant to sell for $1. So let's go back to the browser, please. All right, if you look at my screen now, you can see, well, it's not $1, it's €1, but same difference. This one is, the spec is much lower, 48 megahertz processor, 2 kilobytes of SRAM, 16 kilobytes of flash. The keyboard connector is a PS2 connector, as you can see here. If you take a look, you see that it's PS2 and barrel connector on one side, VGA on the other. Old school, but it's already impressive that you're getting all that for $1. It's 5 centimeters by 3 centimeters, the board. And the thing that's cool is that this has a watts monitor. So it's a cool way to learn how to do RISC-V ARM the way you did on an Apple II. So what is a watts monitor? I'm pretty sure I already explained this once. Let me see. Oh my goodness, don't make me log in. This one I should have really worked out before. 5154. Okay. Excuse us for the interruption. 0. So.
Yeah, I'm not sure what you've been doing there, but you're typing something, but the screen, the desktop screen was saying with the browser is just that UMX webpage. So whatever you're typing into is not appearing.
Yeah, I'm searching for what I wanted to show you.
Oh, okay.
Because, well, I can show you what I'm doing so I don't bore you, but I'm looking for the place where on my Twitter thread about the Apple II, I show how a watts monitor works. So there is this very long story of my Apple II restoration from last year that we've already reviewed in the past. So, but towards the end of this, there should be the monitor story. Okay, see, here is when I discovered this RISC-V board. So this was May of last year. But where is the explanation of how a monitor works? Well, those are monitor commands. But I don't have the tutorial handy. Okay, let's see. This is June.
You'll have to send us the links to that, Federico. That's on x.com.
Yeah. Yeah, that's when I do a retrocomputing project, I usually document it picture by picture as I progress. So it gives me a good way to scroll back into the history. But all right, well, I thought that I had an interaction with the monitor documented here. Actually, I'm quite sure that there is a video of it. So let's try one more time. This one is June. All right, that's a different video. That's a video of the audio system. Well, maybe my memory is faulty. Anyway, well, if there is no video now, I will have to make one. A monitor is a resident program that you would have access to from the boot, the booted system. So the firmware of an Apple II would include what was called then a monitor, and now we call a Wozniak style monitor, since either Woz originated it, or certainly the one that we remember is his from the Apple II. In the original Apple IIs, the monitor was resident in firmware. Later versions of the Apple II, the monitor you would load from a floppy disk. But essentially, it's a small resident program that is just a few kilobytes. And I'm sorry, I'm getting feedback from somebody who unmuted. And what you can do with the monitor is that you can look at locations in memory. You can enter codes in memory. So a very early way to program a system like the Apple II is that you do not even assembly programmer, you do machine language programming. You put the individual opcodes and the individual operands in memory, saying, at this address, this hexadecimal number, at the next address, this other number, and so on. And then you try to see if that executes correctly. And the monitor will let you single step and look at locations in memory, and generally do interactive debugging that way. It's similar to having a basic interpreter, but it's an assembler interpreter. So it's pretty darn cool to learn how to interact with the machine natively. And that's why I thought it was really neat that they made one for RISC-V, because it's a nice way to learn how to interact with the machine. I think that Olimex has a similar system, which is a 6502. So if you want to, go back into the past and play with a 6502, you can do it. But I think that it's more interesting to play with the monitor that they've ported to the RISC-V and learn the new instruction set. So that's the cool part about this. The other things that are here in the box, the thing wrapped here is a monitor, actually an LCD monitor, not a Wozniak monitor. But the parts that are more useful are these, because you need different programmers to flash the firmware onto the board. I have one of the earliest boards because I was planning to write an article about this as early as last year. Then with all of the Red Hat Office move and all that, I wasn't able to do it. But Olimex was very kind, and they sent me one of their first builds, and so it arrived without firmware because the hardware was ready before the firmware was. And in any case, I would have needed the programmers to upload new versions. So those are the approved programmers for this chipset, and the rest are just necessary cables to interface with it and USB power. So nothing too glamorous. Let me see what else can we glean here from the specs. One thing that I thought may be problematic is that this is really a bare minimum PC, right? 48 megahertz, 2 kilobytes of RAM, 16 kilobytes of flash. Doesn't matter. The point is accessing the instruction set. But I suppose almost anyone will have access to a PS2 keyboard, or can get one for a couple of bucks from the flea market, or if not, get an adapter. I don't think that's a problem. But one thing that I was puzzled at the beginning was VGA connector, because VGA is not that common anymore. But okay, you can get an adapter for that too. But this is not VGA as in 1024 by 768 or the high resolutions of VGA. This is the lowest resolution of VGA. I can't remember what it is. 480 by 200 or 480 by 640. It's
I think it was like 20 by 200.
There we go. So in any case, in pixel terms, it's ridiculously. I mean, the text mode of VGA would be perfectly fine. You don't even need the graphic mode. But the problem is that in pixels, you're talking about, I don't know, 200 by 400. The monitors we have now have trouble syncing down to that. So I was afraid that I would not have a monitor that would sync to this. That was me worrying too much. Apparently, most current monitors can still do abysmally low resolution. And it just looks terrible, but there you go. So let's go with the last two boards so I can give time to the other speakers to do their part of the show. So, whoopsie, too many things here.
Thank you, Federico.
Yep. So the last two are most similar to I suspect the kind of processors that Kurt will talk about. Because my understanding is that the higher end RISC-V processors right now either come from Alibaba's semiconductor division or come from Sci-Feed. So let me see what we got here. So the first one, let's go with the lower end one, is this one, Milk 5 Mars, which is still an SBC class system.
I have a Milk 5 Jupiter. Definitely not SBC. It's a full PC. Probably same processor though.
Let's see. I think the Jupiter has an 8-core and the Mars is a 4-core, but let's see if I'm right. Milk v Mars. First Milk 5 credit card sized SBC. Let's see how expensive is this one. Looks like Alibaba is the distributor. I'm sorry, Alibaba. Why doesn't it tell me? Because they have too many. Oh, okay. Let's go back to the specs. High performance RISC-V single board computer. Star 5 JH7110. 4 cores. eMMC. Up to 8 gigs of RAM. Up to is not very interesting. Okay, the one we have here is 4. But apparently there are other versions with more. The SI and the various MIP connectors for monitor and display are there. Nothing too surprising there. 2-lane camera. Claims to have accelerators for H.264, H.265, so you can accelerate video. JPEG encoder, decoder. All right, well, gigabit Ethernet. Obviously, footprint similar to Raspberry Pi as much as possible. M2, there is an M2 PCI here. So, monitor and camera connectors, as we discussed. Looks like the power is USB-C, HDMI, audio, usual complement of USB ports and Ethernet. Not sure what this with this 4-port. Oh, it's power over Ethernet capable. And anything interesting on the other side? Not really. Anything else? SPI flash for bootloader, okay. Where is the eMMC slot? Okay. So this processor is a Star 5 GH7110 RV64GC 1.5 gigahertz. There is apparently a user button somewhere. Oh, here it is. And that header is a fan header. All right. And now the one that Kurt was talking about, the Jupiter. So this is the big cousin, the micro ATX format card, meant to be desktop class. Okay, I'm not showing you the rest of the box, but well, I can show you. There is Wi-Fi antennas, and if you like to set up things neatly in your micro ATX setup, you can, because they give you a mask. And then looks like we never used this board. I certainly never did, but nobody else did either. Okay, there we go. So RDC battery. Looks like we dropped the cover for this connector. I'll have to put it back.
So notably a different processor. That's not a Star 5. It's a Sophon, Softgo.
Yes, you're right. And we can pull up the specs. Octa-core, claiming support for Ubuntu and Fedora, and Vulkan capable GPU. RVA22 profile. RVV10 vector extensions. It doesn't give me a map of the board, which would be neat, but okay. SpaceMit K1M1 octa-core XMIT K1M1 octa-core X.
Okay, that's the new one. The one I have isn't even. It is. They don't even have the latest vector extensions. RVV like 0.9 or something like that. And I understand from attending all these meetings that you pronounce it space time, not space MIT. Don't ask me why. Maybe it has something to do with their logo, but yeah, that's the latest. The Softgo 4602 or something like that. Let me look that up. So that's the specs on the latest Jupiter. The one I have is not quite RVA 22 exact.
Yeah, mine is probably older too. Let me see. No, actually, it's RVA 20. This one is RVA 22. It says 4 or 8 or 16 gigs, but it doesn't tell me which one I have. Let me see. I have. I would have to follow the serial and the model number. It doesn't tell me. Okay.
Yeah, you probably have the new one. Yeah.
I probably have the new board, but not so much RAM. I'm guessing it's a 4. OpenGL ES11, OpenCL3. Some degree of CUDA MV applies. Oh, there is onboard Wi-Fi. That's neat.
So that GPU, so Imagination Technologies either owns MIPS or vice versa.
Yes.
But yeah.
Imagination owns MIPS. So the space-time, I guess, makes sense. If you called something space MIT, probably MIT would have a problem with it.
Yep.
And I guess they're being cute because you read that backwards, but okay, fine. Branding by geeks. Anything else that's of interest here? 1 PCIe slot, X8 slot, 2.1 2-lane. They missed the connector. Oh, there's a full-length connector over here. Nice.
So we have one of these set up at Northeastern University, and Joshua and I have accounts on it, but it's just a pain in the butt to SSH into Northeastern University. We were going to give a ton of accounts away on it, but only Northeastern students that have direct access to behind the firewall have access to it now. So there has been some students that were interested in doing some RISC-V development. So there has been some work done on it.
But once you get past the SSH, how is it?
Very slow, and I've got, so I have Debian testing on there. I think is that the distro we have on there, Joshua? It's I don't have anything even remotely close to a contemporary kernel, and as you know, there's all sorts of interesting stuff in like 16 and stuff. If you want to pull down T-head as your processor, that's right there. You know, all sorts of really interesting RISC-V in the kernel now, none of which we can take advantage of because I've got nothing more recent than 6.8 on there, and that's that came stock. It ships with Fedora, and that kernel. I've tried compiling kernels. I go to the Milk 5 GitHub, and they tell you to download this tree, and none of it compiles correctly. So I'm kind of stuck with Debian testing plus the 6.8 kernel.
I believe that's right. There was also an issue with upgrading the kernel, as I recall.
Yeah, they're not mainline at all.
I see. Okay, so looks like you get a beefier processor, but the BeagleBone is easier to work with. Okay, I think that's what I have. I ran out of hardware, so unless there are questions, I'll hand it over to you, Kurt.
Well, I think in keeping with the theme of the evening, I think I'll just talk about what Joshua and I are working on. I only really have 5 slides on. So I have this. Nominally, I have this description of everything that I discovered at IEEE supercomputing last month, and over the course of the last 3 or 4 years, there has been progressively less and less RISC-V content. So I can shoehorn that into the end or into another meeting. But I think we'll talk about, especially since Josh and I have been talking a lot about what we want to do with RISC-V in pedagogy, which there is going to be a lot of in January because we're going to teach some IAP classes. I think we'll talk. Josh and I will talk about what we want to do, and then certainly we can degenerate into a group discussion. I think that would be appropriate. Do you want to? I don't have access to the slides, Josh. Do you want to share them?
The graphics output one or a different set?
Graphics output one. I only have 5 slides for my description of HPC processors in the RISC-V community. So the
Okay, why don't we do that first, and then we'll stop, and then we'll go through the graphic output one. Does that work for you?
Side first? Okay.
For you?
Yeah. Yeah. It's just that people are going to get whiplash, but okay. Let me do that. Let's see. Do I bump Federico if I start sharing? Maybe I do. Let's see.
I think Federico has to stop sharing his desktop before you can start yours.
Okay. Okay, how's that look?
We can see.
All right. I didn't want to call this that's so I've been collecting up between me and my unpaid copy of ChatGPT. I've been collecting up all sorts of military terms, and I'm going to try to put together a list of everything that's made its way into computer parlance. And I'm sure Jerry appreciates this one. The reason they use the variables foo and bar in virtually every programming book dating back to the 60s is because of the acronym foo bar, which I'm pretty sure it comes from the military, but maybe it comes from before the military. So, and then I don't know where the third variable comes.
My World War II aviation slang dictionary says FUBAR is Army Air Corps.
World War II, not earlier.
It doesn't document it earlier. It doesn't attempt to.
Okay, and I guess they ran out of variable names because there's BAS as well.
I have seen some speculation on BAS as a variation on BAR that gets into some specifics we don't need here.
That may be a regional thing too, because I've heard in some places they use them with flute bar and blitz. I don't know, maybe it's East Coast versus West Coast or something.
All right. Well, IEEE Supercomputing is the biggest IEEE conference, and it's in November every year. And this year it was in St. Louis, and they had 20,000 attendees, and it's almost entirely academic focused. All the papers, all the posters, the workshops, they've got. This is where I first discovered BOFs, WIPs, AMAs, and there's some other three-letter acronym there. And so nominally it's all grassroots generated content. Like it used to be that you could do a BOF and just announce it the day of, but that's all very much regulated now, and your content has to enter into the IEEE access procedure. It goes through some sort of analysis to see if the content's appropriate for publication. Anyway, these were the 5 or 6 really interesting academic projects that I thought were impacting high-end RISC-Vs. By high-end, I mean, so the Xiangshan project out of China is derivative of China. The Chinese government is funding the one student, one chip program where even undergrads, but certainly grad students who are computer science or ECE majors can learn sort of introductory Verilog and RTL to put together a design. And they've got a lot of help there's probably 100 universities that are feeding into the code bases on this. They've done some really interesting 16 and 32-bit RISC-V designs, and they've published that on their website. And they're currently working on a high-end, so RISC-V, certainly 64-bit, but probably an additional 8 or 10 extensions. So C for compressed, D for double precision. Typically you'll find a 64-bit RISC-V processor that says it supports 2 different kinds of numerical notation, vector. So RVC would be compressed and vector. So a lot of the high-end code bases that China is trying to support will have almost 8 or 10 extensions. And if you go to the RISC-V website these days, there's certainly a couple of dozen extensions that are supported already. They're approved, and then there's probably another dozen that are in development and are in some sort of a clock cycle. I've only got one MIT RISC-V core so at MIT, the PDOS department, the Parallel Distributed Operating System sub-department of CSIL, they've got a really interesting processor called the XV6, which apparently, if you're in academia and you want to be teaching computer architecture and have the students follow along on a real world RISC-V, that's a very popular design for that. I've had, there's another sub-department at CSIL and MIT Core 6. Computer architecture, CSG, I believe is what their current name is. They also have lots of RISC-V cores. If you're interested in, 5-stage out of order or 8-stage, so those are also very good projects that are also good for education. They may not be great performance processors, but they're great for education. And a lot of those guys some of those guys that ended up getting graduate degrees from MIT had done some work when they were undergrads at Berkeley. There's a surprisingly large number of people that have academic pedigrees from those two schools, and that's where you learn RISC-V, certainly in the early days. This Czechoslovakian website, he's a professor, Pavel, teaches computer architecture at his university and uses RISC-V. I don't know what he uses for a textbook. The most popular one is Patterson and Hennessy, Patterson being the father of RISC-V when he was a professor at Berkeley. And then there is a Harris and Harris textbook that is also extremely popular if you want to look at computer architecture using RISC-V. A lot of the early days, you see the Patterson textbook from a couple of years ago. He used MIPS or something as his reference architecture. Most textbooks now for computer architecture students use RISC-V now. And there's locally, Rishier Nikhil, he has a free textbook on his website. He talked about it at the RISC-V Summit. He espouses BlueSpec, Open BlueSpec, as his RTL of choice, and all of his code examples are using Open BlueSpec. But the textbook's free. Just download it from his GitHub site and print it out. The HPC lab at IIT, I think that's Bangalore, IIT Bangalore. Yeah, they have they've posted a lot of their Verilog and VHDL, and they are using, I believe they pulled one of the Berkeley designs down from the UC Berkeley GitHub site. Probably Berkeley names all of their RISC-V cores after trains, so this was probably Boom, which the OO stands for out of order. I think they did a variant on the Boom processor. They have so they use BlueSpec, and they've got cores that have eight of these Boom cores and another 8 POSIT cores. I'm going to talk a little bit about POSITs later on. Zero to ASIC is a course. There's a chap in the UK named Matt Venn, and he'll walk people through getting introductory and getting smart on introductory Verilog, and designing a core or pulling someone else's core down as a skeleton and supplementing it, and then putting it into an ASIC. If you're using one of the smaller RISC-V cores, you can stick it into a cheap FPGA. There are cheap FPGAs out there. They're just not very performant. I'll go check the specs on. Federico was talking a lot about the Beagle 5, and there's 23,000 LUTs on there. I think Joshua and I have talked about what can you do. That's the FPGA part. What interesting can you put in there? Now there is at least one YouTube video of a guy who put basically blinking lights into the LUTs, the programmable logic that's in there. So I'll see if I can dig up that video. You can't do much with 23,000 LUTs. You need like a high end, a $1,000 FPGA to get any of these really nice CPUs working. However, if you just want to learn the basics of RTL, then there's plenty of opportunity, including the Beagle 5 Fire. Then at supercomputing, there was really only one RISC-V targeted workshop. Now this is the 3rd or 4th year of the HPC workshop, and it's pretty good. It certainly talks about the state of the art, the state of the state, in both academic and commercial perspectives, which is to say, there's probably 5 companies that are making a living off of selling RISC-V, either RISC-V IP or fully fabbed RISC-V silicon, and these companies are making a living at it. Now, there's not many more than 5. Certainly at supercomputing, Sci5 does not have a booth anymore. They were the first RISC-V company. You still can buy dev boards from them, and you can buy, you can have them do a boutique design if you walk in with your own RISC-V cores or work with them to build something for you. There is a couple of other. I've got a slide for the other companies that advertise there. There is certainly an extension. RISC-V very early on envisioned a 128-bit processor. Now there isn't a whole lot of people interested in that or working on it. However, there is the High Peak conference that's substantially, I think, exclusively in the EU, and they haven't had one in 2025. But there was a sub workshop on RV128 at High Peak. Most of the RISC-V conferences that are exclusively RISC-V are now on the West Coast. We've had some here on the East Coast in the past, but nothing central to RISC-V. We have some peripheral stuff. SecRISC-V is still going on. One of the RISC-V developers that was at Boston University is now at ASU, and he runs not only the RISC-V conference, the SecRISC-V conference, but he has a RISC-V company on the side. And then, of course, you may remember last year, Joshua and I and Alex Brennan and a couple other people ran the FOSSi Latch Up. So FOSSi is the free and open source Silicon Foundation. They are substantially based out of the EU and Norway, and they run a pretty sizable conference in the EU, which is not necessarily it's not limited to RISC-V. It may be most of the designs people talk about there are RISC-V. There's a plurality of RISC-V designers there. However, you see the occasional OpenRISC person, or JCore, or I don't know if there's anybody still working on OpenPower, but these are computer architecture conferences, not necessarily RISC-V. They sort of end up being that way sometimes because of this is the when you're at a university and you're using the Patterson textbook, this is the ISA that you learn in schools these days. So the guy who wrote the book on posits, which is the kind of cores that Joshua and I are quite interested in right now, John Gustafson, also from Arizona State University, he's going to be in Boston next month, and he's going to speak at Northeastern University. I don't have much, and I do have the date, and I've got the room, but I think I'll post that. I'll work with Jabber to post it to a calendar. I don't have a whole lot of details on that, but he will come and talk about his next generation arithmetic, including posits, probably exclusively posits, but he also has a couple of other designs that are better for certain use cases. Posits is kind of his general solution to HPC. He thinks it competes better with IEEE floating point for the kind of usage cases that we have in supercomputing and HPC, and the 300 or 400 codes we've looked at that are CFD, quantum chromodynamics, the ones that are very much high precision, and also, I don't know, a lot of inner loop. So there's ways to fix some of these pathologies that come out of using floating point. Some of them are really great usage cases to make his point. Some of them not so much, but there are certainly usage cases where you can beat a hard float with a soft posit, and he'll be talking about those. Oh yeah, we'll have to talk about this reality hack at MIT, Joshua, because the RISC-V International Foundation is sponsoring it, and I don't really see an opportunity for RISC-V there, but I think they'll probably want someone to go over there and represent the architecture. So the companies I did see at supercomputing, and like I say, there was no big, there's no Intel for RISC-V. There is no, geez, there's not a whole lot of RISC-V companies that will come out and tell you that, we are a chip company and we will ship you either a dev board or an SBC or a wafer or a bunch of chips or a server. That's really not the way that RISC-V entered the market. Sci5 will sell you a dev board, um, and they may even let you have access. They've got at least a couple of years ago, they used to have a sandbox where you could SSH into some of their machines, and if you wanted to see if your code would run on RISC-V, that would be a great opportunity, and those opportunities do exist at places like the Chipyard. Now, there was one other foundation that I need to track down. It was a spin-off of the Chipyard, but they're very interested in, for everybody that's like, maybe you were a RISC-V developer a couple of years ago and now you want to get on the new RISC-V, the new Raspberry Pi that has a RISC-V on it versus the previous ones that had Broadcom ARM chips on it. Well, um, Raspberry Pi might not be a good example because you can just buy one of those, but there's plenty of companies. TensorTorrent will let you log in, and there's at least a couple of people I know that have TensorTorrent black holes and wormholes that will let you, that basically give you a free account, because it's, if you port your code to take advantage of some of these new RISC-V designs, then it's going to benefit the company, and I know TensorTorrent is aware of that. I only just discovered Bolt graphics at supercomputing, and they have a RISC-V. I think they have a board. Is it a RISC-V board? So I'll have to look into that, see if they have a dev board. Codasip is very much involved with the European Processor Initiative. So the EPI is kind of a CHIPS Act for the EU, and they were very bullish on ARM before it got bought by a Japanese company, and now they're much more interested in the RISC-V designs that are coming out of places like the Barcelona Supercomputing Center. SciPearl was involved with RISC-V design for the EPI until recently. I think they've gotten away from RISC-V. Zero ASIC and Zero RISC, I think, are companies right here in Cambridge, Massachusetts. Zero ASIC definitely is. That's Andreas Olafsson's company. He had done the Parallella board and had done it with some. If you guys remember the Parallella boards with the Epiphany chip, he had done this with a couple of his own RISC designs, not RISC-V. I think he may have had maybe more of a RISC-3. The naming convention's kind of awkward. All of these terms come from publications that Patterson had done over the years. But they're calling RISC-V that because it's the fifth iteration of Patterson's work that is the reduced instruction set. All right, let me see if I think that might be everything. Oh yeah, so I was looking for some more background today, and I found this page. So this is off, if you can believe this is from bostonherald.com. First of all, I didn't know the Boston Herald was still around. Second of all, so they've got bots writing articles for them. This tokenring.ai, there is no mention of a human in the loop anywhere in this. And I just found it, and you go, and it's like a contributor to to bostonherald.com is tokenring.ai. So I guess good on you, Boston Herald, found a way to keep the paper alive. But yeah, anyway, that's really, I will revisit some of these topics real soon because of these other conferences that will have happened between now and the end of January. And Gustafson will be in town. Gustafson does have a processor. He's got his company in India called Caligo Technologies has a RISC-V, eight RISC-V cores and another 8 POSIT cores. So he can demo hard POSITs. It's just that, the point he's trying to make with these other numerical notations is, the fact that there's ways to fix this, whether or not you're using, whether or not you've got x87 or IEEE 754 on your processor, because there's a lot of benefits that derive from using these alternative numerical notations, not just speed, but reproducibility, reversibility. There's all sorts of usage cases where you can get rounding errors with IEEE 754, and you don't get that with posits. And I'll make I'll certainly Joshua and I will figure out what our schedule is for IAP at MIT in January, and at least some of those lectures will be public, so and probably streaming. So we'll keep you informed on all that.
I thought a considerable chunk of the experience of getting a PhD was dealing with the numerical instability of IEEE 754.
Oh, is that right? Huh.
When you write code, yeah. It's like, oh, my thing is going to infinity. My thing is going to 0.
0 or -0?
Oh, yes. Taming the code.
I think it was actually the absolute value of -0.
Yep. Yeah, that's one of the. So if you read Gustafson's book, so if you go to posithub.org, the splash page there has a picture of his book. The first 50%, like the first 10 chapters, are what's wrong with floating point. He doesn't even start to make a case for an alternative until like chapter 12. And then, of course, his famous debate. Like we don't have that on the splash page, but we should move it there. He had this famous debate with Kahan, who was one of the he was in at the early meetings with the IEEE 754 committee, and he was like, yeah, John, I'll talk about floating point and the shortcomings and why we made these decisions and stuff like that. It was a very, very famous convivial debate. And so John ended up there's a good, I don't think there's a YouTube of the debate. There is a YouTube of John speaking at Stanford though. And it was called Doing to Floating Point. Oh shoot, what the hell's the name of it? Oh crap, it'll come to me. Doing to Floating Point what Floating Point did to integer or something. And it was pretty witty. And so he's going to revisit a lot of that discussion. We had at supercomputing, he spoke at a number of events, and I think the tide is swelling behind people pivoting to an alternative numerical notation. Probably because it's going to be easier to do now that we've got AI copilots. If you don't want to revisit your million lines of code and say, oh, geez, do I really want to go down that path and have to worry about all of my potential error conditions? It's quite conceivable that with one of these AI co-pilots working right along with you, it'll keep you straight. So we're going to look into that. Certainly, Gustafson's looking into it, and we'll talk about it in January.
First one is this thing that was sitting on my table because I was integrating it recently, but apparently not recently enough because I forgot about it. And it is the latest Orange Pi. So Orange Pi has made revisions of almost anything, and this one is called Orange Pi RV2. So 8-core RISC-5 with the 2 TOPS AI accelerator. So some of the boards that I went over had 1 or 2 TOPS of let's call it Tensor Core. That is close to nothing. Like if we go to the Edge SBCs that I have AI accelerators, even the old Google dev board from 5 years ago has more power than that. But these little bits of AI acceleration are useful if you're trying to run a model like YOLO or something for image recognition, that it's not as massive as an LLM, but still needs a little bit of acceleration. And so I don't know if 1 or 2 TOPS are enough, but and several of these boards have that. And this one has 2 TOPS. So this one is not documented yet. I'm sorry, I didn't label it, but it's somewhere between 2 and 8 gigs of RAM. I don't know which one, the specific. It has 2 M key slots right here on the side, one on top of the other. The interfaces are not in the usual Raspberry Pi format. So one thing that's cute is the header is color-coded, so you don't have to count the pins squinting like you do with all other boards. That is a nice touch. There are actually some headers for Raspberry Pi that are made that way, so that you don't have to deal with that. And here is the complement of ports. So HDMI, a bunch of USBs for, as usual, 2 Ethernets. That's kind of cool. USB-C power. So the board is nothing particularly unusual. There is a reset button over here. Wi-Fi 5 and Bluetooth 5. So latest frequency is covered. Nothing of that scenario I was complaining about before. 8-core RISC-5. Let's see if it tells us KYX1 8-core RISC-5. That's CPU. 2 to 8 gigs. I think this board has 8 gigs, but I'm not completely sure. eMMC can be from between 16 and 128 gigabytes. I think this one is 16, but again, I haven't labeled it yet, so take that with a grain of salt. I'm sorry, I saw a question go by about the USB stack, but I couldn't read it. What was the question?
Are any of those ports actually through the USB stack? So are they actually shared in the way, I can't remember, it might have been Raspberry Pi 4 did that?
It's shared in terms of they're using the same PCI lane, you mean?
Yeah.
I would expect so. I think in almost all SBCs, these ports are coming out of the chip itself. There isn't another chip supporting them. I think that the Raspberry Pi 5 did a little bit better than usual, but almost all of them, it's just a matter of bringing out the pins from the main chip. And so that limits the performance, notably for Ethernet.
Yeah, that's why I asked, since it is nice that there are 2, but I wanted to know if they properly separated them.
Oh, these are actually 4, and they're color-coded, so some of them look like they are 3. I'm reading here USB 2 and USB 3, but I don't know if they're shared, unless proven otherwise. I would assume that the 2 Ethernets and the 4 USBs are sharing.
All right, thanks.
Mm-hmm. This one goes all the way to Ubuntu 24.04, and they say that you can run DeepSeek on it, which would be a more interesting model than YOLO. Well, more interesting in terms of the strain that it will put in there, not more interesting in terms of usefulness, because I don't think you necessarily need LLM running on your SBC, but it depends on what you're trying to do. Now, see what else is here. They are not in the business of giving us a nice spec sheet. Oh, there we go. What did I skip? Display connector and 2 camera connectors seems to be a very common combination these days. Oh, there is actually a 5th. Oh, that's right. There is a 5th USB that I thought was power only, but apparently not. So 5 USBs. Power on button, a reset button, and the boot button. So 2 user buttons and the power button. Okay, let's see if here is anything else of note. Well, there is an audio connector there for, I guess, you want to be able to bring in audio or video for the models to look at. Okay, so that's one, and this one is from this year. And okay, the MK slots, 2 lanes. So at least the PCIEs are independent. Let's see what the price of this is. I don't remember. Oh, $63 for 8 gigs and looks like the 16 gigs is not there. Nice. $77, 128 gigs of eMMC and 8 gigs. Not bad. Sorry, I'm not fast enough to get the chat comments, so I'll have to go pull them up. Okay, and the Google Nano Banana is neither banana pine or not. Okay, yes.
Yeah, Banana Pi is an ARM processor, though.
All right, so that's one. The other one is from the other end of the spectrum. It's this thing here. It's a Milk 5 Duo. So I don't remember who popularized this form factor. Maybe one of the early Arduinos. Anyway, this form factor with 2 rows of connectors has been around for about 10 years to plug into plug boards, so breadboards. So it's been around, but the result is access to anything on the chip is done through pins. This board has exactly 3 things. USB-C for power, a connector for a camera, so that you can bring in video, and what we should call micro SD connector if we paid the licensing fee to the SD forum, but since they didn't, it's called a TF connector, since the TF term is not trademarked. But same thing. And this one, the Milk 5 Duo, there are two variants, 64 megabytes and 256 megabytes. The 64 meg version starts at $5. So it's in the same class as the Olimex. But while the Olimex was 48 megahertz, this one is a 1 gigahertz core with, I presume, dual means dual core. Let's go see the specs. So this board here on the table is a Duo 256M, which means it has 256 megs of RAM, I believe. And like the latest chip out of Raspberry Pi, it has dual core ARM and RISC-V, and you can choose which one. So this one has C906 1 gigahertz and C906 700 megahertz dual core RISC-V CPU. And on the ARM side, there is one core Cortex A53 at 1 gigahertz. 256 megs of RAM, 1 tera operations at int 8 to run your small model and recognize those images, I suppose. Oh, that's funny. They use the micro SD word here. Trademark violation. Well, TF connector. There is some NAND on board for the bootloader as usual. And USB Type-C for power and data. Sure. CSI connector, we already covered. It says that you can do 5 million. I take this as 5 megapixel at 30 frames per second. The Ethernet over USB will get you to 100 megabits. And 5 volts, 1 amp, so it's very power considerate. We'll skip the spec sheets, but you can see the connectors here. Type-C, camera socket, SOC, and TF socket. And then here these pins are Ethernet, if you care to wire them. And the other ones, as I was saying, you have to bring out what you need, either with a soldering iron or with a breadboard. You can do something very cool with ARM boards in this format, so I'm not sure that I would necessarily go with RISC-V to animate the various Halloween contraptions that I've made with the equivalent boards for ARM, but maybe at some point. So yeah, this one is pretty cool for $5, I would say. And it's the absolute low end of the Milk 5 spectrum. And finally, last thing, now I need to make sure that you are all switched over to my browser window, because I'm going to show you the stuff that we were missing about what the monitor is. So the videos do exist. So here is the first one, if you are switched over to Federico's desktop. Here is the start sequence of an Apple II. PR6 is basically load boot from floppy, right? Here is starting Apple ProDOS, nothing too interesting, but what's relevant is that square bracket prompt. That's the typical prompt interface here. Here, early days of plug and play, you can scan what's in different slots, and because they control the origin to some degree, they can identify the cards pretty well. So 1970s plug and play. Now, this machine has integer basic and floating point basic, depending on whether you boot the Apple basic or the Microsoft basic. But once you're in the monitor, you can use the syntax that I was describing to dump memory. For example, here on this capture, 0.99 is dumping the first 100 bytes of memory, and you can see what's in there. And of course, I'm making jokes about memory protection, because I can just go and grab things in memory and write things in memory. And you can see here, where am I saying? Here I'm saying 620, put byte 55 in there. And you can see up there in the corner, there is a flashing U. I've literally written that letter into the memory of the frame buffer. Or in this example here, I'm writing these bytes sequentially at location 610, and there are the numbers flashing here, the letters flashing here. I'm overwriting the frame buffer and writing them on screen. But the place where it gets really cool is that you can tell the microassembler that's part of the monitor to disassemble in mnemonics a piece of memory. So instead of you reading the machine code that you translated by hand, byte by byte on your notepad, the machine itself will do the translation for you and tell you what the opcodes for the 6502 are, which is a lot more civilized. And so what you can do with the OLIMX board is that you can play the same way with a RISC-V processor. It's a very low-end processor, no operating system. It's an MCU straight from machine start into program, right? But you can do exactly the same thing and learn RISC-V assembler live, poking at the monitor and single stepping through the program and disassembling it in memory. So it's a very nice hands-on experience if you need to learn assembler. And so if you are interested in all of this, you go to my Twitter, which is 0xf2, and go back to May 14th, 2024. And there are probably 100 of these screenshots as I'm going through the different steps. And quite a few of these are also in the session that we did about retro computing last year. And you will also see that I'm learning the differences between two different Apple IIs, because different versions of the Apple II had the monitor in the BIOS, in the firmware, and newer ones had it in floppy so that they could free space in their firmware. There were different behaviors, whether you started from Wozniak's integer basic or Gates floating point basic. And so I'm basically fumbling through these things until I figure out the full picture. Like, for example, this funny thing that you start the monitor by saying call -151, which, what? But you're calling a routine in memory called 151, and that's what's starting the monitor. Anyway, we're not going down the retro computing rabbit hole here, but it's a good show of what the monitor is and how it works. And I think the one for RISC-V now is complete, so you can realistically do the same thing with the OLIMX board. Okay, that's it.
Thank you, Federico.
Mm-hmm.
Federico, I don't know if I told you my Apple II story. It'll be quick. I know I've told.
I've heard your next stories, but not your Apple II story.
Oh, my Apple II story. So back in the days when Apple Fest was competing shoulder and shoulder with Macworld, I had I used to go to Solomon Schechter School in Newton, and I was a member of the Apple II BCS group. And BCS, said, "Hey, we've got a booth at Apple Fest. Why don't some of you guys come and work the booth and bring your Apple IIs?" And so I brought my Apple IIe, and just it was back then. There was just a lot of it wasn't very techy. A lot of walk-ins, a lot of people that were new to PCs. So I'm busy
Install
talking
fest
to
kind of
somebody.
environment.
Yeah. So I'm talking to somebody, and I see Wozniak walk by, and I'm like, "Oh, here's my opportunity." So I pull the lid off my IIe, and I run over, and I say, "Hey, can you sign the lid of my IIe?" So he does, and I was like, "Oh, this is going to be worth some dough in the future."
Oh, I heard this.
Fast forward about 2 months, 3 months, I loaned it to my parents, and they brought it to their school, so that the students could, I don't know, do some database work on it or something like that. And when I got it back, it was clean as a whistle because the domestic staff had thought that that someone had put graffiti on this wonderful piece of high tech, and they they washed it down and washed Wozniak's signature off of it. So it was like, okay, well, guess it's only going to be worth $1,500.
Well, you can get Watts to autograph it one more time for you.
What was the machine that his signature was part of? Was that the 2GS or something? There was a big Woz signature on it.
I don't know actually. I know there are a few signature sets inside the case of the early Macintoshes. And then, as the case got retooled, the signatures started disappearing because they didn't really take the mold the second time. But the early Macs have Jobs' signature and most of the Mac team, but Woz was not one of them, I don't think. And one of the Amigas, I can't remember which one. I think maybe the 1200 had signatures somewhere inside.
Yep. Well, if I can find it, I went to one of the early RISC-V events where they handed everybody a High Five 1, and that had like Chauncey's signature on it and Patterson's and Christie.
Nice.
Yeah. So and these things couldn't support Linux, so it wasn't enough SRAM on there. So Josh, maybe that's one of the ones we can hack U-boot into or something and see if we can support something on it.
I believe that Woz has a website where you can ask him to sign anything. So if you still have your Apple II, mail him the lid, and for a cheap, low price, he will sign it for you.
Yeah, and he has to use indelible ink this time. One of President Trump's pens, not one of those
or spray painted
markers
with the lacquer or something after you get it.
With a stencil.
I have something signed by Woz somewhere here, but I don't know where it is. It's when he wrote his memoir, he went on a book tour, and I remember he signed the copy. He's remarkably consistent in how his signature looks like.
Yeah, true.
So, Jabber, since my voice is breaking up, I think we're going to have to delay the recording the missing minute. But since you have me again in January, maybe we can do it in January.
Yeah, I guess. That means more delay before posting the video.
Or we can meet during the holidays. It depends on how much annoyance are you willing to tolerate on your schedule. I'm working through the holidays because IBM doesn't shut down for Christmas. I mean, yes, they do shut down for Christmas, but not for the window between Christmas and New Year like Red Hat did. So I'm available if you want to do it next week or something like that.
Yeah, you think you'll be over whatever it is by then?
Sure.
Last time I had the flu, it lasted me several weeks.
Yeah, every time I take a plane and go somewhere far, I catch a flu and I keep it forever. It's really annoying.
I haven't had that problem in ages, though, ever since they started getting the vaccine.
It's yeah, I don't know what is going on, but it's not even that, because I don't have any other symptoms except this cough. Anyway.
Okay. Well, okay, if you're not up to it today, then sure, we can do it later.
Yeah.
Okay.
All right. Anything else?
No, apparently not. Well, thanks, Federico, and Kurt and Joshua, too. I think this is a good meeting.
Thank you all, and have a happy holiday.
Yeah,
Let's talk again soon.
Likewise.
guess I can stop the recording now.
Good night.
Yeah, good night. Oh, come on now.
Okay, good night, everybody.